We're going to continue our focus on pyramid measurements with a look at surface area. There are two types of pyramids. Those that are regular have a base that's a regular polygon, and those that are not regular. And the strategy, the approach to surface area for those types of pyramids differ. First of all, let's look at surface area of a regular pyramid. Again, a regular pyramid is a pyramid that has a base that's a regular polygon. In this case, I've got the base is a hexagon. What I've done is I've cut along the edges of the lateral faces of the triangles to form a net. Again, nets are very important in middle school because nets allow kids to focus on the meaning, on the concept of surface area. So you cut the pyramid along the edges, unfold it, and you have this star-shaped figure. The area of this figure then would be the area of the base, and to find the area of the base, which is B, you would divide that base into triangles. Each of the triangles has altitude or an apothem of A and a base, the side length S. So the area of each of these triangles would be 1/2 A times S, multiplied by the number of triangles you have, and you have the area of the base. The area of the lateral faces, which are the triangular sides, to do that, you know that the base of each side is S, and the altitude of each side, since they're regular, each of these sides would be the same. We're going to call that the slant height, which is L. So the area of each of those lateral faces is 1/2 L times S. But you have, how many do you have? So let's see, in this case you've got 6. So you would have 6 times 1/2 L S. I'm going to bring the 1/2 L and S out front. So this is the lateral area, it's called. The lateral area is 6 in this case because it's a hexagon times 1/2 LS, which is 1/2 L, the slant height, times 6S. But the length of each side is S. There are 6 sides. So 6S in this case, because it's a hexagon, would be the perimeter. That leads to the lateral area of the pyramid, which is going to be 1/2 the slant height times P, because 6S in this case is the perimeter. Add the area of the base with the lateral surface area, and you have the area formula for surface area formula for a regular pyramid. Let's look at that in the context of a problem. Here is the same volume or pyramid that we used to examine volume. First of all, we have to find the area of the base, as we did before. The area of that base. There are 5 triangles. Each triangle has a altitude or a height, or excuse me, an area of 1/2 area of the length of the base, which is 7.625, times the altitude of the triangle of each triangle on the base, which would be the apothem of that base, and that would be 5. So 1/2 times 7.625 times 5 is the area of one of these triangles, but you have 5 of them, and so 5 times that, which equals 1/2 times 25 times 7.625 inches squared, because its area would be the area of the base. Now, the lateral surface area, which is the area of each of these triangles, to do that, what I need is I need the slant height. And the way you get the slant height is you draw this triangle. You've got the altitude is 12. You've got the, in this case, the apothem is 5. So I'm going to use the Pythagorean theorem. The slant height, which I'll call L. Okay, so L squared equals, we've got this right triangle, 1 leg squared, 5 squared, plus 12 squared. That equals 25 plus 144, which equals 169. So L, the slant height of each of these triangles, would equal the square root of 169, which equals 13. So this is the area of the base. The lateral area, since for this pentagonal prism, there are 5 faces. So there are 5 faces. The area of each face, lateral face, is going to be the length of the side. So it's a triangle, so 1/2. Length of the side, which is 7.625, times the slant height. Again, what I've done is I've unfolded this pyramid. I've got, these are the sides, these are the lateral faces. 7.625 is the base. The height, which is the slant height of each of these triangles, is 13. So 5 triangles times the area of each of those lateral triangles, 1/2, 7.625 times 13. Find the base area, find the lateral area. So the surface area would just be the area of the base plus the lateral surface area. Okay, that's for a regular pyramid. Now let's see what happens, how it changes for a non-regular pyramid. For non-regular pyramids, again, for regular pyramids, the surface area is the area of the base plus 1/2 times the slant height times the perimeter. But here's the problem with a non-regular pyramid. And remember, non-regular pyramids are pyramids where the base is not a regular polygon. In this case, I've got a pyramid that is a rectangular pyramid. One side is side 1, one side is side 2. Because of that, what I'm going to have is I'm actually going to have 2 slant heights. So for this smaller triangle, I've got a slant height of L1. For this bigger triangle, I have a slant height of L2. So what I like to think of is really no formula for the surface area of a non-regular pyramid, but I'm going to say think of it as a strategy. What we're going to do is we're going to add the area of the base. So in that case, for this rectangular pyramid, that would be S1 times S2, since it's rectangular, it's the area of the base, plus the area of each of the lateral faces. So in this case, I have the area of the 2 skinny triangles. There's 2 of them. Each triangle has an area of 1/2. The base is S1. The slant height, or the altitude of the triangle, is L1. Plus the area of the 2 wider faces. There's 2 of them. Each of those wider faces is a triangle, so it would have area 1/2. The base, which is S2, times L2. Now notice if I had something really obscure like a hexagonal prism where none of the sides was the same, I'd have 6 different lateral faces and 6 different slant heights. So in other words, there really is no strategy for a non-regular surface area, or surface area of a non-regular pyramid. Just find the area of the base, the area of the side, so this is the lateral area, add those together, and that equals the surface area of the pyramid. So let's look at a quick example. Here's a rectangular pyramid. One side is 60 centimeters, the other side is 80. So I know already, and I'll do this in a different color, say black. I know the area of the base is going to be 80 centimeters times 60 centimeters. 8 times 6 is 48, so times 10 times 10. So that is going to equal 4,800 centimeters squared. Now, each of these faces, so let's look at the faces that have a base of 80. The slant height is big H. Okay, so here's the slant height for the face of 80. The altitude of this pyramid is 45. So what I need to do is use Pythagorean theorem to find big H, the big slant height, or one of the slant heights. 45 is the height, it's one of the legs. This other side is going to be half of 60, so this will be 30. So what I will get is I'll get that H squared equals 30 squared plus 45 squared. That will get me big H, okay, the one slant height. So H in this case will equal the square root of 30 squared plus 45 squared. Again, I don't have a calculator, but we can figure that out. So the area of the two sides with a base of 80, there's two of them. So we'd have 2 times 1/2 times the length of the base, which is 80, times the length of the slant height, which would be H, which we'd find by finding the square root. Now, we also have to find the surface area of the sides that have a length of 60. That slant height is going to be different. The slant height, which on this figure is little h, again we have one leg is 45. This base leg of the blue triangles is half of 80, so that is 40. So h squared, little h squared, equals 40 squared. This is for the blue triangle, plus 45 squared. So h is going to equal the square root of 40 squared plus 45 squared, whatever that turns out to be. There are two lateral faces with a base of 60. So each of those there'd be two of them, times they're each triangular, so 1/2 the length of the base, which is 80, times whatever we find when you'd find this square root, times h. That would give me the area of the two lateral faces with a side length of 60. So we take the length of the base, add it to the length of the sides with length 80, add that to the sides with base length, this should be a 60, sorry about that, 60, and that gives us the surface area of this non-regular rectangular pyramid.